Alrighty. Hi, I am Russell Wolf, and this is what's new in Kotlin Multiplatform. So I will done this a couple of times, but I'm still not used to giving online talks, so bear with me a little bit. But yeah, I'm a multi-platform developer at TouchLab, where we build apps for various clients using Kotlin Multiplatform, and we'll talk a bit about that. So we, being an Android conference, know that Kotlin is not just an island in Russia, but it's a programming language. And it's the preferred development language for Android.
Ja, ich kenne da. Und ich habe gerade das Cropping eigentlich reingemacht, aber...
Sorry? I'm hearing some feedback. Maybe it's fine. So yeah, Kotlin is not just on Android, but JetBrains developed it originally because they wanted a language to write their IDEs in. It's also become popular on in JVM server-side development. And in addition to those JVM platforms, you can also run Kotlin on JavaScript, targeting either the web browser or Node.js environments. And more recently, you can target native platforms via LLVM and interop with C APIs. And relatedly, you can target iOS and other Apple platforms using targeting Objective-C APIs. So Kotlin Multiplatform is what binds all of those different platforms together. So it gives you a structure to have common code that you can compile to multiple different of those, like to any of those targets, and then platform-specific code, which lets you interop with APIs on that platform. So the way that you may be used to in the Android world, talking to Java APIs from Kotlin, you can also talk to JavaScript APIs from your JavaScript framework. In JavaScript, you can talk to C APIs or iOS APIs from your Kotlin native. And what this enables is the flexibility to share the bits of your code that make sense for your use case without needing to share everything and without needing to create abstractions for everything. So one of the pain points of many other multi-platform frameworks that comes up in things like React Native or Flutter is the difficulty of doing things that are easy in native because you have to go through this kind of shared abstraction. So I work with Kevin Galligan, who likes to quote himself in his talks like this. So I figure maybe it's slightly, he likes to make fun of himself for quoting himself in his talks. So I figure maybe it works better if I quote him. Shared UI is a history of pain and failure. Shared logic is the history of computers. So Kotlin lets you share the bits of code that make sense to share without needing to share everything. And what that lets you do is, share what makes sense. It avoids needing to kind of add extra abstractions that just make your work harder. And that's not just for UI, that's also for other platform-specific things. So maybe you're doing, maybe you have some permission-related logic that behaves differently on Android and iOS. And you don't have to create a shared abstraction around that because you can just talk to the native APIs directly. So Kevin's allowed to quote himself. I'm going to quote myself too. I've been saying for a while that mobile is the killer app for Kotlin Multiplatform. So yes, the thing that's great on multi-platform is that it gives you lots of flexibility to share what you want to and not share what you don't want to. But mobile is this awesome use case where there is a lot of parity between what you want the two platforms to do. Like users generally expect Android apps and iOS apps to have the same features, to do the same things, and they get confused when they don't. Like you get confused if there's, or you get annoyed maybe if there's an app that has a feature on one platform but doesn't have it on your platform. Because the kind of expected UX of these platforms is so similar, it's a great use case for doing this sort of code sharing. And I'm not the only one who thinks so, because JetBrains has been doing a lot of investment over the last couple of months in talking about Kotlin Multiplatform Mobile as a specific use case. So they have now a team that's dedicated just to working on mobile-specific things, whether that's improved tooling, documentation, samples, but making sure that not only does Kotlin Multiplatform work in general, but that it works for mobile in particular. And while I'm talking about Kotlin Multiplatform Mobile, I should mention the kind of alphabet soup of acronyms that we get sometimes in this space. In the early multi-platform days, you would often see MPP as an acronym thrown around, which is multi-platform projects or multi-platform programming. And that essentially means the same thing as KMP, which is Kotlin Multiplatform. KMM is now the new acronym that is specific to mobile. So that's Kotlin Multiplatform Mobile. So if you hear those terms thrown around, that's what they mean. So let's talk a bit about what all of this looks like. So how is your shared code structured? And the mental model that I really like is this kind of Venn diagram. So on the left side, you have the Android code that you're used to writing if you're just kind of an Android developer. And you can kind of split that out into stuff that knows about Android and knows about the JVM and kind of talks to those APIs, and stuff that just knows about common abstractions like the Kotlin standard library. So that's the stuff that lives in the center. And that's the code that can then also run on iOS. But iOS gets not only that, it also gets this outer layer where it can talk to, like your Kotlin iOS code can talk to iOS specific APIs. So you can talk to like things like UIKit and things like that. And this isn't just a metaphor, this is also like how the build system works. So when you build your Android app, it's going to put the Android sources together with the Kotlin sources. And when you build the iOS app, it's going to put the iOS sources together with the Kotlin sources. So that like that visual metaphor kind of helps you understand what is going on as these things are put together. So zooming out a little bit, what does the kind of like wider architecture look like? So that Venn diagram becomes this module in the center that's common code with an Android library and an iOS library. The Android and iOS apps then kind of consume that library module, and it looks to them like any other library. So most importantly, it doesn't make it any harder to pull in any other native dependencies. So that's that flexibility where you can share a lot or you can share a little depending on what makes sense to your use case. And there's also an ecosystem of libraries that's available to your multi-platform code that has implementations on both platforms that they can make use of. So what does the code look like then? So common code looks kind of like, it looks like Kotlin, right? It doesn't have access to everything, but you can do all the things that you expect to be able to do in Kotlin, such as create classes, properties, functions, talk to things like the collections API, use different stream operators. And it's worth pointing out that if this was all that you could do, it would still be pretty great, right? Like you can, if you have like some complicated piece of business logic, if all you could do was just like write it in common and then call into that from somewhere else, like that would still give you a lot. But sometimes you do want your shared code to be able to talk to platform-specific things, and there's various ways to do that. So the thing that the multi-platform build system adds to the language is the expect actual syntax. So your common code can expect any kind of declaration. Here it's a value property, and then the platforms can inject their own platform-specific implementation of it. And I do like to think of this as a sort of dependency injection, where there's going to be an exact one-to-one match between the expect declaration and the actual declaration per platform, and the build will fail if it's not there. So that's really nice if you want to kind of wire your things together and make sure that everything you're expecting is there, but it has certain inflexibilities too. So when expect actual doesn't do what you're looking for, you can still use interfaces the way you always might have. So you can define an interface in common, give it an Android implementation and an iOS implementation, and then pass that to your common code, and your common code can talk to things by the interface the same way that you might do dependency injection in a single platform world. One of the nice things here is that iOS implementation doesn't have to be in Kotlin. It could be in Swift if it happens to be easier to write it that way. And you also get the ability to swap out limitations for things like testing. So when you're using expect actual, that actual declaration is already in place by the time your tests are building, so you don't get an opportunity to kind of swap out with a fake implementation. But if you use interfaces the way you might traditionally, that gets easier. It's also worth pointing out, this doesn't just have to be an interface too. This could be something like a Lambda that you pass into as an argument to some other structure. There's lots of different ways that you can structure your shared code to be able to pass this sort of thing in. So that is the kind of whirlwind tour of what Kotlin Multiplatform is. But this talk is supposed to be what's new, right? So let's talk about what's new. And one of the things I should not forget to mention is with Kotlin 1.4, JetBrains has done a lot of codifying of what they mean by their different preview releases. So Multiplatform has promoted from experimental to alpha. And what that means is JetBrains is committed to making that, like, improving and developing that use case over time. So while something is experimental, like maybe they reach a point where it's not useful enough or not working in some way, and so they abandon it. But by making it alpha, they're saying they're committed. So there might be breaking changes along the way, and there probably will be as things get refined. But they're committing to continuing to support it over time, which decreases the adoption risk if you're interested in trying it out. So with that in mind, let's talk about some of the new stuff. And one of the most exciting things, I think, actually, is they've done a lot of refreshing of their documentation. So a big pain point in Multiplatform over the last couple of years has been, like, this just kind of started in earnest about 2.5 years ago. And the docs haven't always kept pace with changes to the framework. So it's been a common pain point that, like, you start Googling something and you find a tutorial, a blog post or something that's out of date in the advice that it's giving you, and it's hard to know what's correct and what isn't. And even a lot of stuff on the official doc site would be out of date, could be like a year old or something, and that was a long time. But they made a bunch of changes. So as part of the investment in Kotlin Multiplatform Mobile, there's now this KMM portal page that talks a lot about different use cases, the library ecosystem, things like that, and it includes a big collection of new mobile-specific docs. So there's things about project setup, about different APIs that you might want to use. There's some notes on things like how you might want to organize your team and how you might want to kind of communicate Kotlin things to the iOS side of your organization, for example, and also like more technical topics like concurrency. So definitely check that out if you haven't yet, and if you're looking to kind of find more information about all of this. They've also done a lot of refreshing of the not mobile specific documentation. So there used to be this building MPP with Gradle page that was like the one page in the official Kotlin docs that was consistently up to date that you could point people to say, like, here's how Gradle gets configured. Now they've broken that out into a bunch of different pages. That old link like doesn't even exist anymore, which I find funny now. But there's a whole bunch of new information and kind of more organized information that is now up to date on that page. So check that out if you've been avoiding looking at the official docs because they've been out of date. So in addition to docs, there's a bunch of cool new tooling things. And probably the one of the exciting ones that's been on a lot of people's mind is the Android Studio plugin. So at Kotlin Conf last year, JetBrains announced that they were working on a Android Studio debugger. And yeah, so that has been released now. And it does a couple other things too. So you can find it in the plugins list in the IDE. It's called Kotlin Multiplatform Mobile. And yeah, it gives you a couple different things. So it gives you it adds a new template to the new project dialog that will give you kind of a pre-configured Kotlin Multiplatform Mobile application. And the ability to set up run configurations for the application so that you can launch your iOS app from Android Studio. And then you can also, to use debugger, you can just run that, run that run configuration in debug mode, essentially. It doesn't always work perfectly. I've had a lot of trouble getting it to work in more complex scenarios. It does work if you just set a breakpoint on that initial template if you want to try it out. But I think there's some iterations still to be done there, and I owe a couple bug reports about that. So yeah, definitely try this out. Report bugs if you see them. JetBrains is looking for feedback on all of this stuff. But in addition to the Android Studio plugin, so we at TouchLab maintain a Xcode plugin for debugging Kotlin. So this lets you kind of from the more native iOS context set breakpoints within your add your Kotlin code to your in a way that's visible to the Xcode project, and then separate points in there, and yeah, debug your Kotlin code that way. So that's been around for a little while. We've updated it so it works with Xcode 12 now, and the install process is a lot more streamlined. So if you're digging deep on this stuff, it's worth playing around with. And then there's they've done a lot. JetBrains has done a lot of work on a new project wizard for IntelliJ IDEA. So I mentioned the new project template that the KMM plugin has. The IntelliJ has a much more configurable thing where you can create a mobile application that looks pretty similar, but there's also a lot of flexibility to, they have a bunch of different templates for different use cases, and the flexibility to kind of configure it manually. So that project structure tree on the right there, it gives you a preview of what the different templates look like, but you also have the ability to set up whatever modules you want. So that can be nicer than setting up that folder structure manually if you were doing that previously. Especially for more complex scenarios, that can be really nice. So another kind of tooling related topic is the concept of they've been doing a lot of work in Kotlin Multiplatform on the what's called the hierarchical project structure. And what that means is, so we've talked about in the intro about having common source in the center and individual platform sources on the outside. But oftentimes you actually want to kind of share between some platforms and not the others. And so you want these intermediate shared source sets. And it has always been possible in the compiler to do that. But what's been tough is the IDE didn't know how to infer what APIs are actually available in that shared source set. It's still in progress and it doesn't work for every scenario yet. But there's some support now for having, for example, a shared native source set, or a shared, Mac OS and iOS source set, or native, particularly for native platforms that share pretty similar APIs. This can be pretty useful. It doesn't yet work if you have multiple tiers of shared things, but I think that should be coming in the future. And there's a ticket somewhere that you can start for that. And the way that all works, that you can opt into it, is with these two flags and Rails properties. So if you're trying this stuff out and you're having trouble with the IDE support, adding these Rails properties can sometimes help. So what else is new? Threading kind of gets its own category because there was a big announcement a couple months ago around the Kotlin native threading model. So if you've been working with Kotlin native for a little while, you're probably aware that Kotlin native is very strict about not being able to share mutable state between different threads. And this helps it deal with its red discounting and memory management internally. There's been a lot of pushback from various parts of the community about this. So JetBrains finally this summer announced that they're going to pull back from that model and develop something new. The long and short of this, though, is it's not going to be a fast process to come to that. So if you're kind of jumping into the stuff now, you do still need to know your way around the memory model. But like I wouldn't expect to see any even early release of it before probably sometime next summer. But we will eventually come to a point where the way that we do that multi-threading will change. So just have that in mind as you're jumping into this stuff. So next we'll talk a bit about libraries, and I'm going to mostly focus here on the JetBrains libraries because they're pretty foundational, and I'll have kind of some big things changing around the Kotlin 1.4 release. And we'll start with Kotlin X coroutines, which is the library support for the coroutine APIs that we're probably mostly all familiar with as Android developers. So this gives you like support for things around suspend functions and flows. Definitely check out Flow if you haven't yet. Flow and SafeFlow, they've been doing a lot of work on not having not just suspend functions, but also more reactive stream like abstractions. So that like more of the use cases that you're used to from things like RxJava are supported. And all those things exist across platforms, with the caveat that the mainline release of coroutines is only single-threaded on native. And single-threaded doesn't mean that it can't do background work. It's just that coroutines can't manage the threading of that work, which I'll talk a little bit more about when I get to Ktor. But right now, coroutines is kind of managing two separate versions. So there's kind of a mainline version, and there's the native MT version, which is a multi-threaded release that has some risk of memory leaks. But if you're careful with it, it lets you do native multi-threading. So it's definitely I would recommend using the native MT version if you're able to, but be aware that those two are different. It's very easy to accidentally pull in a dependency that uses the native MT version without expecting it. And that's something I've see people kind of asking questions about every so often, or getting confused by. So just know that there's a difference there, and pay attention to what version your dependencies are pulling in. And one of the common culprits of that actually is Ktor. So as of 1.4, the Ktor HTTP client, which lets you do web requests from your common code, uses the native MT branch on the native side. So that can lead to a couple different hiccups. One is what I just described earlier, that you might not have been expecting it. And the other is that a bunch of the Ktor APIs can now free a state that you might not be expecting, which can lead to runtime errors. So you have to, when you're working with Ktor in 1.4, you have to be a little bit more careful about what outer things get captured in the scope of the lambdas that go into the Ktor configuration. There's a bunch of bugs that get reported that not all of them are actually bugs. Sometimes they're just confusions around that memory model. There's also Kotlin X serialization, which just had its first stable release, which is pretty exciting. So that's it's a very it's a broadly a format agnostic serialization library that works from Common. So the JSON serialization through it is like fully supported, and there's a couple of experimental formats as well, and the ability to define your own format, your own serializers, and things like that. So if you've been using it for a while and you haven't yet upgraded to 1.4, be aware that with that stable release, they made a bunch of breaking API changes at their because they wouldn't be able to do it later, essentially. So most of them have deprecation annotations that make it easier to migrate, but be aware that it might be kind of like a large source change when you're doing that upgrade. And they've also added a bunch of new docs, which are really nice for walking through how to do custom serializers and how to do custom formats and things like that. So if you're interested in digging into how all that stuff works and customizing it, definitely check that out. On the more experimental side, there's been a first preview release of a datetime library. So this has been a long-standing kind of request from the community to have a common data abstraction. So the Kotlin team has finally put one out as of a month or two ago, a little longer now maybe. So check that out if you're interested in it. One caveat is that it has a fairly, it's got a pretty small API surface right now. And so JetBrains has said, if there's things that it doesn't do that you're looking for, they're interested in hearing what your use cases are. So give them that feedback. Make sure that the library can do what you're looking for. Give a quick mention to Jetpack Compose, which is not yet mobile multi-platform specific, but the Compose UI toolkit that the Android team has been working on for Android now has a preview release that JetBrains has made for use on desktop as well. And they're talking about doing a JavaScript version. So they haven't explicitly talked about iOS yet as something that they're committed to doing, but I wouldn't be surprised if it kind of shows up eventually. So keep an eye on that if you're interested. And then, of course, there's a whole bunch of community libraries that, continue to be updated. So some of the core ones include SQLite, which gives you maintained by Square and gives you a common SQLite database. I maintain a library called Multiplatform Settings, which is a simple key value store for things like sort of a common replacement for shared preferences. At TouchLab, we maintain a couple libraries, including Stately, which gives you a bunch of tools for dealing with the current Kotlin native memory model. So we'll see what it looks like for that library long term, but it can be pretty useful if you're doing stuff right now. There's a couple different dependency management things like Coin and Codeine, and a whole bunch more. I used to give talks and I'd be able to list pretty much every single library that exists, and that's not true anymore. So there's a couple different lists online you can find that Akira repository has a good list of them, as well as that mobile or KMM portal has a list of different libraries as well. Talked about ecosystem. The other part of the ecosystem is sample code and how you can kind of find guidance and examples and things to base your structure off of. So there's a bunch of these that are listed on the portal pages. I'm going to talk about some of them, some that aren't, some that aren't. TouchLab, we maintained a sample called Camp Kit, which includes it's both a template project and a big pile of docs. I'm talking about kind of our state of the art and our development practices. And the idea of the template project is to have something that works right out of the box. A common problem historically has always been the kind of getting started process in KMP, where teams would like set aside a week-long hackathon or something, and they'd be halfway through the week before they finally had something building. So we created CampKit as a way to kind of kickstart that process, so you can get something that runs right away and get to actually working on your own code. So if you're looking to try things out and have kind of like a slightly more complex starter than you get out of the new project wizard, check that out. I also want to mention John O'Reilly has a couple of nice samples. So CampKit focuses on like what are the sorts of design or of architecture choices that you might be making for something that's going into production in the near term. John's stuff is really nice because it's all using things like Java Compose and Swift UI. So it gives you a nice preview of what the world might look like a little further down the road once we're doing a lot more sharing and we have these two much more similar UI frameworks on top of them. I also have this other project that I maintain personally called Multiplatform Hello. That's sort of a full stack application demo. So I haven't talked about this one much, so I figure I should probably start mentioning it every so often. It gives you it has like a shared data model between server and clients, and then shared client logic between Android, iOS, and JavaScript, just for like a simple web call that passes a single message. So it might be a nice platform to test out different configurations if you're doing like a larger, if you're sharing between more different platforms than just mobile. And then, yeah, once again, there's a whole lot more on that KMM portal. So check that out if you're looking for more demos. All right, almost done. Here's a bunch of links to other resources, and I'll share the slides out so that people can get access to all the links that have been all the way through. If you haven't been writing down fast enough or taking screenshots or something, sorry. So those first three are some of the docs pages that I mentioned earlier. There's also a nice code labs page on the right-hand side. So if you'd rather try things out in a hands-on way, there's a bunch of Kotlin Multiplatform and Kotlin native related code labs on that page, as well as other general Kotlin things. I also put out a roadmap page recently if you want to get a sense of where are things going and what are kind of the priorities for the Kotlin team right now. So you can kind of get a sense of what to expect in terms of future developments. And then lastly, CampKit is on there again. So that is the end of my talk. I'm just going to quickly plug a couple other. So right after the session, my colleague Kevin Galligan is going to be giving another talk on some more production-specific considerations. So check that out if you want kind of some more details there. And then the TouchLab team is going to have a kind of roundtable chat tomorrow if you want to ask questions there. So, all right, I have some questions in here. So on the top of the list is, how can I use multi-platform to access Android and iOS specific APIs, such as shared prefs and user defaults? So two answers there. One is you can use an expect actual or passive interface the way I described at the beginning of the talk. The other is you can use my library, multi-platform settings, which does exactly that, and you can just interact with it from common. So yeah, thanks for giving me the opportunity to do that plug. Next, is Kotlin Multiplatform Mobile ready to be adopted for production level code, or is it still in an experimental state? So it's in a alpha state rather than an experimental state, which means like what production level means is kind of different for every team. If production level means you can use it in production, the answer is yes, because there are people that are, and like we are building apps for clients that are. But every team has its own tolerance for what experimental means and what I guess what unstable means. So if you're willing to accept the risk that some of the things that, like some of the APIs that you talk to are going to change from underneath you, and you're going to have to make some adjustments to deal with that, you can do things now if you're willing to accept like the risks of some things being not as like not perfectly performant or things like that. But if you're not a very risk tolerant team, then like it's definitely in the early adopter phase right now. But I definitely recommend trying it out, seeing if the state that it's in now is a good fit for you, because it definitely is possible to use virtual right now. Next, are the changes to threading and the Kotlin native memory model expected to be breaking for existing projects? So they've said they're committed to not breaking existing code. It's hard to say very definitively without knowing kind of what changes they're going to make. But especially after seeing how how the coroutine API is stabilized and they put a lot of effort into making that migration path easy, I would expect something similar for Kotlin native for the memory model changes. But I don't have any like insider knowledge around what that will look like because I don't think they've made all those decisions yet. Next, is it safe to deploy a CAMM library in production? Could there be breaking changes? I think I've answered that in the previous questions. Are there any tools for Xcode which can pull the shared code as a dependency instead of building the pod file and manually importing? So I'm not personally familiar with them. There are a couple things I've seen with people experimenting with like Swift package manager integrations, things like that. You also can do you can kind of wire the framework in manually without using CocoaPods, if that's your preference. We're doing a lot of thinking internally around what we think the best kind of recommendation for teams for some of this stuff is, especially if you're trying to a lot of kind of common KMM samples have everything in a single repository because that's the easiest way to kind of get up and started. But larger teams don't always want that. Still kind of in progress on what the answer is for larger teams in the long term, but there are options. So that's not a great answer, but it's an answer. Just grab a drink of water because my throat is dry. On the problems of KMM, do you have any regarding platform-specific lifecycle? Not really. Like the part of the advantage of sorry, I'm switching that. Part of the advantage of not sharing all your code is like things like lifecycle can remain platform-specific considerations. So like you can have your shared code have just like a initialize and deinit kind of API, and then plug that into the platform-specific lifecycle where you need to. And I'll finish on this last one at the top here. In the long run, will a Kotlin developer be able to call him or herself an iOS developer as well? I think what will actually happen is you'll be calling yourself a mobile developer, and you'll be doing things on both platforms. But ideally, over time, you stop thinking of yourself as kind of wedded to a single platform, but instead get this kind of superpower, or some people have called it, of like being able to deploy things to both. And that I think is like really the way that this technology can kind of empower teams to do more. So I think that is time, right? So I can, if anyone has further questions, I'm happy to follow up offline. You can definitely reach out to me on the Kotlin Link Slack or on Twitter. So thank you very much.